All right, let's dive into a really fascinating challenge in the world of AI. How do you actually get a model to follow complex, multi-part instructions without, messing it up? It's a way bigger problem than you might think, but the solution? It's pretty darn clever.
So, have you ever had this happen? You ask an AI to do something specific, like, hey, summarize this article for me in 3 funny bullet points. And what you get back is a super serious 5-paragraph essay. I mean, it got the summarize part, sure, but it completely ignored 3 bullet points and funny. It's that kind of frustration that actually points to a really deep challenge in how these things are trained.
See, here's the thing. The core of the problem is that we're not just asking an AI to be right. We want it to be right and concise and formatted perfectly and helpful, all at the exact same time. It's this incredible balancing act, and, well, sometimes one of those balls just gets dropped. So how do researchers even begin to teach an AI to do this? Well, the main method is something called reinforcement learning, and it's actually pretty simple in concept. You basically give the AI positive feedback, or rewards, when it does the right thing. So it makes sense, right? If you want it to learn multiple things, you just give it multiple different rewards. Honestly, the best way to wrap your head around this is to think about training a puppy, right? You're not just teaching it sit. You want it to learn a whole bunch of things at once, like fetch the ball, but also don't chew on the furniture. And that's pretty much exactly what AI trainers are doing with these big, complex models.
Okay, so for years now, the industry standard for this kind of multi-reward training has been a method called GRPO. You can think of it as the go-to technique, the established playbook for getting an AI to juggle all those different goals we were just talking about.
But what if that standard method, the one everyone's been using for ages, has a hidden fundamental flaw? Well, that's exactly what a team of researchers over at NVIDIA started to suspect. They found this subtle but really significant issue just hiding in plain sight.
Okay, let's go back to our puppy, because this is where it gets really clear. The problem with the old method, GRPO, is kind of like this. Imagine you use the exact same excited tone of voice and the exact same tasty treat to praise your puppy for fetching the ball and for not chewing the furniture. What's going to happen? Over time, the puppy just gets confused. The praise for 2 totally different good behaviors just starts to blend together. It has no idea which action is more important or what you're specifically rewarding it for.
And that is exactly what the NVIDIA researchers found. They called it a collapsed training signal. Basically, all those distinct rewards for different things, like being accurate versus being concise, were getting all mushed together. They were just losing their unique meaning in the middle of the training process.
And look, this isn't just some minor technical glitch. A collapsed signal makes the training way less precise. The AI literally can't tell the difference between the rewards, and that leads to much worse performance. In fact, the paper points out that in some cases, it can cause the entire training process to just, fail completely.
So, obviously, after discovering this, they knew they needed a whole new approach. You can't just keep using a method that's fundamentally confusing the AI, right? So they went back to the drawing board to engineer a better, much more precise way to handle all these multiple rewards.
And that solution is called GDPO. The most important word here is decoupled, because unlike the old method that just lumped all the reward signals together into one big mess, GDPO is built from the ground up to keep each and every signal separate, distinct, and crystal clear. So how does it work? Well, the idea is actually pretty straightforward. First, you lay out your separate goals, say accuracy and formatting. Then you create a totally unique reward signal for each one. The real magic happens during training because the AI learns using these completely separate or decoupled signals. And the result? You get an AI that understands its goals so much more clearly and can balance them way more effectively.
All right, let's bring our puppy back one last time to really see the difference. GDPO is like this. You use a super excited, good boy when the puppy fetches the ball, but you use a nice, calming scratch behind the ears when it leaves the furniture alone. See? The puppy knows exactly what it's being praised for in each case. The signals are totally clear and distinct. No confusion. Okay, so the theory sounds great, right? The puppy analogy totally makes sense. But the big question is, does it actually work better in the real world? Well, the researchers put it to the test to find out.
And the results were, they were incredibly clear. They put GDPO head-to-head against the old GRPO method on some really tough tasks. We're talking math reasoning, coding, even using external tools. And in every single category, the new method, GDPO, just blew the old standard out of the water.
And I want to be clear, this wasn't just a small improvement. No, we're talking about a major leap forward in performance and reliability. Just by keeping those training signals clear and separate, GDPO lets the AI reach a whole new level of skill across the board.
You know, the research paper itself really says it best. They found that GDPO wasn't just better in one little niche scenario, it was consistently better across all settings. And that's huge because it proves the method isn't just effective, it's something that can be applied to all sorts of different AI training challenges.
So, okay, what's the big takeaway from all this? Why should you or I care about some technical tweak in how an AI gets trained?
Well, it matters a lot, actually, because better training methods directly lead to better AI tools for every single one of us. It means AI assistants that are way more reliable and, let's be honest, a lot less frustrating to use. It means AIs that can finally understand and follow through on all parts of your request. And ultimately, breakthroughs like this are what speed up the process of building AI that is genuinely helpful and capable.
And that really leaves us with one final big thought. As we ask AIs to do more and more complicated things, maybe the real challenge isn't just about making them smarter, it's about making them better listeners. The real quest is to figure out how we make sure it hears all of our instructions, not just the simplest one or the loudest one in the mix.